Welcome to Angles Outside the Circle podcast. All right, so now look where our angle is. It's outside the circle. There's a relationship between angle X, which is over here, arc AB, which is right here. There we go, there's angle X. And D disappeared somewhere. Arc CD, which is right here. Right? See if you can figure out what that relationship is. Maybe pause the tape for a second and see what you think it might be before I tell you. It has something to do, there's a relationship between those numbers. Look at those numbers, 90, 40, and 25. They have something in common, and I'll tell you what the something's not. It's not that they're divisible by 5. That just happens to be a coincidence from the numbers I chose. But see if you can figure it out. Pause the tape for a second, figure it out, and then come back and hear what the relationship is. All right, so see you in a minute. All right, so welcome back. Let's see. Well, what if we were to multiply 25 times 2? Gee, that would give us 50. What if I were to subtract 90 minus 40? Well, that would give me 50. Maybe I could put that together. I've got the difference of the arcs, and I've got the angle times 2. They both equal 50. So gee, if they both equal 50, that would mean that 90 minus 40 equals 25 times 2. What if I just wanted the angle by itself? I didn't want that times 2 there. So instead I wanted to be equal to 25. What do I have to do to both sides? Well, if I want this to be equal to 25, I have to divide by 2, right? So if I divide one side by 2, I divide the other side by 2. Right? So that means 90 minus 40 divided by 2 equals 25. Would that be true? Well, 90 minus 40 is 50, and 50 divided by 2 is indeed 25. And guess what? That gives us our equation here. So I've got the difference of the arcs. Right, here's the difference. So the difference of the arcs, and not just the difference, half. Right, half the difference of the arcs equals the angle. That's our formula for angles that are outside the circle. Right? We're going to take our angle is going to be equal to the difference of our arcs divided by 2, or times a half. So did you figure it out? Maybe you didn't figure out the whole formula, but did you notice that 90 minus 40 was 50 and 25 times 2 was 50? Or maybe you noticed that 90 minus 40 divided by 2 was 25? If you did, you figured out most of the formula. All right, so let's look at this. And now we have 3 different scenarios here of how this angle could be formed outside the circle, depending on whether this angle was created by tangents, by secants, or by a secant and a tangent. The nice thing is there's not a whole lot of formulas to memorize on this one. So 2 tangents, 2 secants, or a secant and a tangent. The 3 theorems for the intercepted arcs to the circle of 2 tangents, 2 secants, or 1 tangent and 1 secant are summarized in the pictures below. And I just gave you the pictures. If you look at each theorem, you really only need to remember one formula. The angle formed by the intersection of, because we liked that so much, we put that twice, of 2 tangents, 2 secants, or 1 tangent and 1 secant outside a circle equals half the difference of the intercepted arcs. Right? So it doesn't matter what makes those that angle outside the circle. The formula is the same. But there is something a little bit different about the 3 scenarios here. Right? Let's take a look at that after I read this last part here. So, therefore, to find this angle, just take the larger intercepted arc, subtract the smaller intercepted arc, and then divide that difference by 2. It's always larger minus smaller divided by 2. And that'll always give you the angle outside the circle. But notice there is a difference. And the difference has to do with how much of the circle the arcs take up when it's two secants, a secant and a tangent, or two tangents. All right, so notice here, if I have two secants, those arcs do not intersect. So the arcs do not intersect. They're not necessarily, I mean, one of them is definitely a minor arc. The one that's closer to the angle will always be a minor arc. The other one, is there any way for that to not, it is almost always a minor arc, but that's not really that important. But the arcs do not intersect. If we look at the secant and the tangent, those arcs intersect in one point. And you should add this to your notes. If we look at the two tangents, the arcs intersect in 2 points. So what does that mean in terms of us solving? Well, nothing different in terms of setting up the equation. The difference is going to be, in case number 1 with the two secants where they don't intersect, we're going to have to be given enough information to find, either we have to be given the two arcs or enough information to find those two arcs, right? If we're looking for the angle measure. If we're looking for the angle, if we're looking for one of the arcs and we already know the angle, then we'll solve for one of the arcs. But between those two arcs and the angle, we have to know 2 out of 3 pieces of information. Where the arcs intersect in one point, notice that a whole bunch of the circle's been taken up with those two arcs. And because a whole bunch of the circle's been taken up, we don't need quite as much information to be able to solve this, because notice here we only have 3 arcs, right? We have the two arcs that are made by the angle and that one other arc. So we could be given less information because we actually have a way to solve with less information and a little bit less. Now look at two tangents. Those two arcs take up the entire circle. I don't have to be given a whole lot of information to be able to work with that, because I already know one thing for sure. I know that that blue arc and that red arc add up to 360 degrees. So sometimes on two tangent problems, I'm not given a whole lot of information because we have ways to find that information because those two arcs take up the whole circle. So you might have to do a little bit more on those problems. So that's really the only difference is on the two secants, you have to be given just a little bit more information than you do on the two tangents, which means you might have to do just a little bit more work for the two tangents. But let's get to solving so you can see how it all works as soon as the page turns. And I'm going to start with two tangents. So let's do the one that's got the most work. Let's take care of that one right off the bat. Two tangents. All right, so angle ABC is formed by two tangents intersecting outside the circle. The arcs formed by the two tangents encompass the entire circle. The major arc, in this case, we will have a major arc and a minor arc. The same thing with the tangent and a secant. We'll have a major and a minor. But with the two secants, often they're both minors. But our angle here that is formed outside the circle is going to be equal to half the difference of our intercepted arcs. So let's solve some tangent problems. See what I mean by not being given a whole lot of information? I have an x and I have a 70. I have nothing else. How am I supposed to solve? Well, we can solve this because while we don't know a lot, we know enough. We know that this much here is arc X, that's arc AC, right? And we know this much is the other arc. the major arc, right? The arc on the other side. So it's where the angle intersects the circle, right? We have the arc that's inside and outside. And on the other side, I guess you want to say. And notice those two arcs take up the entire circle, right? So arc ADC plus arc AC take up the entire circle. They add to 360 degrees. Well, we know what arc AC is sort of, right? We know it's x. So what does that mean arc ADC is? Well, if we subtract x from both sides, we have an expression for arc ADC. So on these problems, right, it may be that you're only going to be given one arc, and you're going to have to subtract. So often you will need to subtract whatever expression you're given, expression from one arc, of one arc. That's not a very good sentence. So often you will need to subtract the expression of one arc from 360 to find the other arc. Right? So we did that, right? So we have the 360 minus x, and we have the x. Let's set this one up. So it's going to be the angle, right? So angle B here is equal to the difference of the two arcs. So arc ADC minus arc AC divided by 2. Angle B we know, that's 70. Arc ADC is 360 minus x, and AC is also x, and then divided by 2. Often it's helpful to multiply both sides by 2. In this particular problem, I need a little bit more space. It really won't make any difference at all because we're going to end up with even numbers, right? But because sometimes we don't, maybe we'll divide. Actually, no, in this case, because we're going to end up with nice even numbers, let's just divide them both by 2. So we have 70 equals 360. Please don't say that's 0x. Right? Negative x plus negative x, that's negative 2x divided by 2. You do have to divide both terms by 2. So 70 equals 180 minus x. And a better way to think of this is we'd have to factor out a 2 here. So only do this if the numbers are both even. Otherwise, you may have a harder problem to solve. So I could say that 70 is equal to 180 minus x. And now all I have to do is subtract 180 from both sides. So that gives us negative 110 equals negative x. And divide by negative 1, 110 is x. Right? It only asks us to find, well, it didn't really ask us questions here, but we're finding x. Right? What if we multiplied both sides by 2? You'll see we get the same answer. So we could solve it this way because both of those were divisible by 2. Or we could solve it this way. 70 equals 360 minus 2x, and then divided by 2. And if we multiplied both sides by 2, right, that would cancel. And so now this is, I probably should put parentheses there, make it look more like multiplication. 140 equals 360 minus 2x. Subtract 360 from both sides. So it gives us negative 220 equals negative 2x. And then if you divide both sides by negative 2, you still get 110 equals x. So you see, you can either divide both terms by 2, not just one, or you can multiply both sides by 2 and get rid of that divide by 2. I would only divide by 2 if they were both even numbers. So there we go. Now, we should probably check it just to make sure it works out, right? So we have 70 equals, and then it's the larger, right? So 360 minus, let's get the number here. So this one here was 70, was 110. 70 was the angle I just wrote down. This one was 110. Right? And that means this one would be 360 minus 110, or 250. So 70 equals 250 minus 110 divided by 2. It's a nice thing to always check your work. 70 equals 140 divided by 2, which is a true statement. 70 equals 70. And there we go. Look at that. We solved it. This one is one of the harder problems to solve with the angles outside the circle, and that's when we have a two tangents. Let's kind of compare. So I know this has been a little long, this podcast, and you had another podcast. Look at that. But we'll do the other tangent problems in class. But let's just compare that to one tangent. So let's do one of the one tangent problems. So let's see how long it takes me to change the page this many times. Probably not going to be pretty. Two tangents. For some reason this problem is twice. Don't think it needs to be. We'll get rid of that one. Keep going. How long will it take me? Oh, spinning ball of death is not good. Two tangents, two secants. All right, so let's take a look about two secants. All right, so angle ACE is formed by two secants outside of circle O. The intercepted arcs are minor arcs here. In this case, we know they're minor because they're 80 and 20, which is less than 180. Arc AE and arc DB. And just like before, it's going to be half the difference of the arcs. But you see, here we had to have a lot more information because the two arcs together didn't equal the whole circle. And actually, this is a pretty easy problem to solve, right? Because x here is equal to 1/2. Oh, by the way, I don't know if this one's in your notes. It might be 80 minus 20. So x is 1/2 of 60, or x is 30 degrees. Right? And you could always just kind of plug it back in, but this was pretty easy solve. I don't know that you really need to check this one, but 80 minus 20, that's 60. 60 divided by 2, that's 30. Right? 30 times 2, that's 60. That's the difference between those two arcs. So yeah, that's the right answer. So you do have to be given a little bit more information on these, which sometimes makes them a little bit easier. Let's do one more with two secants. Maybe it won't be as easy. And it'll be this one that's coming up any day now, right now. There we go. All right, so now this one, a little bit trickier, right? Because I don't know this arc over here. We don't know that arc. So we'll have to solve for that arc. How could we find it? Well, let's see. Is there a way we could find this arc over here? Let's just call this arc, let's put letters here. And this one's probably in your notes. Let's call that AB. Could we find AB? Well, notice that AB is a diameter. Right? Which means that that arc is going to be 180 degrees. Well, together, the three arcs, right, the one that's arc AB, this 100-degree arc over here, right, and the arc that we need, guess let's call it AC. Let's have another letter there. Arc AC there, together, those three arcs make up the entire circle, right? All three of them together equal 360 degrees. So if we add up arc AC plus the 180 degrees for arc AB, plus the 100 degrees for arc, I guess we'll call that CE. Right? That's going to add up to 360. So that means that arc AC plus 280 equals 360. And if we subtract 280 from both sides, 80 degrees is all that's going to be left for arc AC. So, but now, I think we've seen this problem. It looks identical to the one on the last page now, doesn't it? So you see, sometimes you have to do a little bit of work, but once you've got the values in here, this problem's not too hard to solve at all, because x here is just going to be equal to half of 80 minus 20, which, just as it was on the last page, is half of 60, which I believe is 30 degrees. So the solving was super easy. The only difficult thing was setting this problem up. Right? So there you have two secants. And then we'll do some more secant problems in class. Oh, should we even venture to try a secant and a tangent? Well, it might take me too long to scroll there. And you've already seen the hardest problem, two tangents, and the easiest problem, two secants. So I guess we'll save the middle problems, the tangent and secant, for class. So bye for, I did change the page. Well, maybe, oh, look at that, it's going. Yay, secant and a tangent. So let's go ahead and just do a secant and a tangent problem. All right? So secant and a tangent, same formula. It's just sometimes I could be given a little less information because these two arcs intersect. But other than that, solve the exact same way. Angle B here, I haven't written over here. Measure of angle ADB, ADB. Well, yeah, ABD or ABC. Doesn't make any difference. ABD is equal to half of AD minus half of arc AD minus arc AC. So our angle here, ABD, is going to be half of AD, which is this arc over here, minus that arc over there. So angle ABD is 1/2 of 70, or 35 degrees. That's starting to look like a 20 there. 70, 35 degrees. All right? So all of these really are solved the exact same way. It's just sometimes we could be asked to do a little bit more because we can figure out a little bit more when the arcs intersect. Let's maybe do one more really quick problem. And it's a problem on the next page, and then we'll save all the other problems for in class, because I'm hoping to finish this lesson on Monday. Right? So here, this one is very similar to some of the problems we looked at with the two tangents. And actually, I think I'll save this one because I don't want this nearby to go too long. So I'm going to pick up with this problem and all the other problems we skipped in class on Monday, and hopefully we'll finish all of this up. So have a great day. Thank you for watching this podcast. And so just remember, when we looked at two different relationships in the two podcasts. If the angle's inside the circle, right, the angle is equal to half the sum of the two arcs. If the angle's outside of the circle, it's equal to half the difference of the two arcs. Right? So further away it's moving from the circle, smaller our angles get. All right, so thanks for watching. Bye for now.